In this video, I'm going to show you how to use NTAG203 tags using the CR95HF reader writer. So these are the things I'll be covering. We are going to see the activation sequence, how the tags are activated, the memory structure. We're going to see the locks. Here I mean the static locks and the OTP. These 4 points I'm not going to cover here again because this is exactly the same like the ultralight tags which I covered in the previous video. So the thing that is new in this tag is the dynamic lock bytes and the counter. I've already made a video on NTAG203. This was done a few years ago, and I would advise you to see those videos. So I will try to cover some of the points in detail in this video, and this is going to be a multi-part because as I said, I'm going to cover information in depth. So if I go to my video channel, which is called Finite Pi Videos, and I have got a playlist called Read and Write to RFID Tags. If you scroll down, I have made 2 videos that speaks about the NTAG 203 and 203 part 1 and part 2. The software is more or less the same. I have got the same structure, but the only difference here is these videos are based on the MFRC 522 and the PN 532 reader writer. So why do you have to learn NTAG 203 tags? For all the students, this is the easiest tag to understand. This is something similar to the MIFARE ultralight. So there is no buzzwords like authentication or encryption, decryption stuff here. This is also very cheaper to buy. So you can buy this for 35 up to 35 pence, and they are available in plenty. I'm going to show you where to buy these tags, and these tags are NFC forum type 2 tags. So I've not made any videos on the NFC tags. So if you want to write the NDEF messages, and this will be the cheapest tag to use. And some of the applications of these tags are used in the smart posters or inventory tracking. So if you're looking for a free app, there are so many apps in for Android. You can look in Google Play and look for the keywords tag writer, and in fact the NXP, the manufacturer of this tag, they themselves have written an app where you can read and write to these type of tags, and there are so many free apps as well. I have used these tags in a software. I did this for event management. It's some kind of a conference registration and conference entry type of software, and I did this a couple of years ago. I did an Android app using a software called App Inventor from MIT. So App Inventor, they support NFC read and write. If you want to buy these tags, you can buy this from eBay, or you can also buy from so many websites, but I buy most of my tags from eBay because you get a good price here. Just go and type NTAG 203 tags, you get so many listings here. Probably by the time you try, you might find a better price than this. If I take for example, okay, look at here, a pack of 10 costs £4, and here something like that. So on an average you can buy these tags for less than 50p. Okay, The next thing is, as we did in my previous videos, to understand these tags you have to get access to the NTAG203 datasheet. I just did this in the Google. You get so many hits here. I just want to mention, something about. I don't want to click any of these links. I want you to try and open the PDF. I have got my own copy with me. So I just want to mention something about the first link. It's called the smarttagfocus.com. I buy a few things from them. They've got a exhaustive list of RFID related tags and reader writers and so many things. And here, go-to tags also is very popular. Um, they've got a nice software to write uh, NDEF messages to these tags. You can visit their site. And basically, there's so many links where you can download NTAG203, and so you can. So for some reason I don't see any download links from NXP. So looks like NTAG 203 is not very popular. Probably they are probably becoming phased out or a bit outdated, I suppose. But for students, for us to learn, that's the best option, because anything that is not very popular, outdated, you can buy for a throwaway price. So you can get access to one of this documentation. And so let's start using NTAG 203 now. So you can see that I have connected my the discovery board based on CR95HF, and I wanted to show you something before I start. So when I bought this NTAG 203, if you just noticed here, as soon as I bought this near, you can see the LED glowing. So looks like this board is configured to auto detect. That's interesting. So what I did was, because this is a sticker, so I have used this on a blank a plastic. You can buy these blank cards. These are just a plastic cards, and in fact, now if you want to buy this pack of 10, probably you'll be end up paying more than a pack of 10 of this NFC tags. Okay, so I have done this. I'll be using like this, so that easy for us to place it. So I've seen sometimes if I just place this the sticker right here, so sometimes I had a problem detecting the tags. So rather than having a paper a bridge like this, this is what I did in my previous video, and you can place in there. So you can either use this or this method. So if you can grab a few business cards, or you can also use, if you got any of a business cards, the paper one, you can use that as well. Okay, so let's start learning then. So this is the state transition or the activation sequence and the state diagram of NTAG 203. If you compare this with the MeFair ultralight, this is exactly the same. So I have already spent enough time explaining this diagram, so I'm not going to cover here. So it's easy for you to understand this. So this is what we'll be looking for, because for a developers we have to understand the memory organization. And if you have noticed here, the top section, right from the page 0, page 1, page 2, page 3, and a part of this user memory, this is identical to the MeFair ultralight. And the only thing that is new in this tag is the last two pages. That's a page 40, 41. So you can see this tag has got more pages. That means it has got more user memory, and it also got features to as a counter feature. So there's a 16-bit counter and also the dynamic clocks. So that's the only difference between the NTAG 203 and the MeFair ultralight. So we have been seeing this software, and So I've connected here. So first I'm going to connect this software to the board, and as you can see here, I've added one more entry for NTAG203, and gradually you're going to see more and more tags here. So I'm going to choose NTAG203, and this is the screen I have written. There are a few enhancements here. So before that, I would like to show something different here. So I just now mentioned that the top section of NTAG203 is identical to the MeFair ultralight. So I'm going to read this tag as a ultralight tag and see whether it works. So activate. The activation sequence we have seen, I spent enough time with all these, we explain all these commands here. So activation is done. Let's try to read. So the read can read reads only the top 16 pages. So this is what the MeFair ultralight have. So it just, you can read and write and everything works as usual. This so in fact, if you ask me about the way I wrote this software, so I started a new screen for 203 starting from this existing screen, and added a few extra tabs for NTAG 203 specific features. So now this is how most developers do. So we call this as reusing the tags. And so I'm not going to explain anything that is already covered in the MeFair ultralight. So I'm going to close. Let us try this time with the new screen 203. The first thing we do is activate. It's the same activation sequence, and as you can see here, this is the same. So yeah, let's see what's the difference here. Okay, now as I mentioned, the NTAG 203 has got a counter, so I added a section to play with the counter. I'm going to spend a separate session on explaining this counter. And the locks, so there is a new feature called the dynamic locks. So let us try to read this, bring this entire data. So somehow it says it cannot read. I don't know, somehow I'm getting this error. So let us try to halt and activate again and read. Yep. So probably now, don't know whether something to do with this, the way I placed the tag, or is it because the tag is resting on the board. So just you have to play with that. Now as you can see here, the read tag reads the entire memory, and this tag has got 42 pages altogether, starting from page 0 and page 41. See, the user memory here, it's more than the ultralight, so there are more user memory. And finally at the end you got the dynamic locks, so you can read and write. Let's try to do a basic reading here. So writing, so I'm going to write to page 4. Say for example, say n tag right here. So write maybe successful. Let's go and say, so this is just the same, the write command. We have seen this in MeFair ultralight. So this is the write command. So A2 followed by 4 bytes followed by the data, and this is the response. So again, just I don't know if I covered this in the previous videos. The response here, look at that. The response for read tag is 80, where response for write tag it is 90. So because if you see this, the MeFair, the write command, the response is always less than 8 bits. I know response is 0A, so either you get ACK or NAK. So this response is just a 4 bits. It's either A or its NAK could be 0, 1 or 3 and so on. So the 09, I've just been through the documentation of CR95HF. it says if the response is 09, it means the 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 data from the CR, so from the tag, is less than 8 bits. It's not a complete byte. So that's what it means. So just that, probably know what it is, so you probably can understand now better if you go through the documentation. So the read is successful, everything is the same. So the next thing you can play with, there's something you have to keep in mind here. Any new tag you buy, um, that will always come with some data in the OTP. Just compare this with the MiFi Ultralight. In MiFi Ultralight, the OTP was all zeros, whereas here the OTP has got some data. So if this is the case, then I cannot use NTAG203 for a ticketing application, where OTPs are very common for ticketing applications. So this is because NTAG203 are NFC forum type 2 compatible tags. So when these are manufactured, they come with an empty, this basically it's called as a NFC, a type 2 format. So it's already ready for storing an NDEF or NFC data. And I'm not going to cover here because I know that E1 is some kind of a magic number that tells this tag has got or formatted for NFC data exchange. So next thing, we are going to, let's go and see what are the dynamic locks and what's the counter. So what are the dynamic lock bytes? So dynamic lock bytes are used to lock the additional user memory. So if you compare this with the static lock, the static lock is used to lock the first 16 pages, whereas this NTAG203 has got more additional user pages, so we need some mechanism to lock these pages as well, and that's the purpose of this dynamic locks. Just like the static locks, you can see both lock and the block locking bits, and if you compare this with a static block, in a static block, one bit, so used to lock only one page, whereas here a single bit can lock more than one pages. And usually these dynamic lock bytes are present at the end of the user memory. So I'm going to show you the structure of what the documentation says about the dynamic lock bytes, and then you are going to play with the tag. So if you refer to this page number 12 of the documentation, you can see this is the structure of the dynamic locks bytes, and there are only 2 bytes here in the dynamic locks. Some of the higher tags, which you are going to see in my future videos, you'll come across 3 bytes. So as you can see here, the dynamic locks are present in page number 40, and we know that every page has got 4 bytes. The dynamic locks bytes are present in the first 2 bytes. The first byte is what it is. So if you look at here, this bit, the bit 7, can lock the page 36 to 39. So here, so literally we are blocking 4 pages. So single bit blocks 4 pages. So like that, the second bit number 6, also it can lock page number 32 to 35, and likewise. And there are so many bits like this. You can see RFUs, so this is for the future use, and we don't have to worry about them. And we know that NTAG203 has got a counter as well, so even the counter can be locked. So I'm going to speak about counter later. So if you can see here, say this bit, that is the bit 0 of the byte 2. So just have to make a note of this. The documentation or this product calls this additional log bytes as byte 3 and byte 4, whereas the static log bytes are called byte 0 and byte log byte 1 and 2. So, you know, to put in simple words, because there is additional memory, because there are some additional pages, there has to have some mechanism to lock it, and that is what the dynamic log bytes. And to use these locks, you'll end up playing with the individual bits. So this is something you do while programming. And you can also have what is called as the block locking bits. So here, if you look at this, say for example, this bit, it says block locking bit 1 to 3. We know that block locking means to lock even this bytes itself. So the way you understand this wordings here in a block locking bit 1 to 3, so this bit here can lock the bit 1 to 3. So if I set this bit to 1, I cannot modify the bits from here. So assume that you don't want user to lock the pages, so then you can set this bit to 1. Likewise, so you got block locking here, and this bit here, this is block locking bit 5 to 7, that is set to 1. You cannot modify the individual bits 5, 6 and 7. Likewise, there we have to have one more for, if you look at here, sorry, this one I was wrong. Okay, this one is a block locking for the counter, whereas this is the page locking. Okay, so this bit here when set to 1, so will prevent a user modifying this locking counter bit. So the concept is the same. So we have seen this block locking. Even the block locking existed in static log bytes also. So more, it's the same concept. Just you have to keep in mind the block locking locks any modifications to this log bytes.